Charles' law, Avogadro's law, Graham's law of diffusion. So now we are going to prove those gas laws with the help of this kinetic gas equation and the postulates of kinetic molecular theory of gases. Now let us discuss those gas laws one by one. First one is Boyle's law. Robert Boyle derived a relationship between properties, that is measurable properties, volume and pressure of a given mass of gas at constant temperature. According to Boyle, at a given temperature, the volume of a given mass of gas is directly proportional to 1 by P, where T and N are constant. That is, temperature and the number of moles of gas are constant, or V is equal to K into 1 by P, or PV is equal to K, that is constant. This is Boyle's law. So we have to prove PV is constant for a given mass of gas at constant temperature. At constant temperature, PV is constant. That is the task that we have to prove with the help of this kinetic gas equation. This kinetic gas equation, PV is equal to 1/3 Mn C square, can also be written as PV is equal to 2 by 3 into 1 by 2 Mn C square. There is no difference. PV is equal to 1/3 Mn C square can be written as PV is equal to 2 by 3 into half Mn C square, because 2 cancelled and the remaining thing will be 1/3 Mn C square. Now, kinetic energy of a single gas molecule Ke is equal to half mc square. Half mv square is kinetic energy. Here, instead of velocity, we are taking RMS velocity. In place of velocity, we are taking RMS velocity. So it is half mc square. So the kinetic energy of n molecules will be half mn c square. So this half mn c square is kinetic energy of n molecules. According to postulates of kinetic molecular theory of gases, kinetic energy is directly proportional to absolute temperature, or kinetic energy is equal to K into T. So Ke is nothing but Kt, but Ke is equal to half Mn c square. So half Mn c square is nothing but K into T. So in place of half Mn c square, we can write K into T, where K is a constant and T is absolute temperature. Now we can rewrite this kinetic gas equation as PV is equal to 2 by 3 into K into T. Instead of half Mn c square, we are writing K into T, because half Mn c square is the kinetic energy of n molecules. Kinetic energy is directly proportional to absolute temperature. So kinetic energy is equal to K into T, where K is a constant. So small k into T is nothing but kinetic energy. Kinetic energy is nothing but half Mn c square. That's why PV is equal to 2 by 3 into K into T. Here in this expression, 2 by 3 is a constant, K is a constant. If temperature T is also constant, if you multiply or divide a constant term with a constant term, again you are going to get the constant. So while multiplying three constant terms, the sum PV is equal to constant. PV is equal to constant. PV is equal to constant. When PV is equal to constant? When temperature is constant condition. So when temperature is constant, PV is constant. It is nothing but Boyle's law. So we are proving Boyle's law with the help of kinetic gas equation. Task is proving Charles' law with the help of kinetic gas equation. First, let us see what is Charles' law. According to Charles' law, at constant pressure, the volume of a given mass of gas is directly proportional to its absolute temperature. At constant pressure, the volume of given mass of gas is directly proportional to its absolute temperature, or that is P and N constant. P and N condition is there. It is directly proportional, only P and N are constant. If they are variable, this law does not apply. Now, V is equal to K into T, where K is a constant. Proportionality constant. So, V is equal to K into T. Or V by T is constant. That means K. V by T is constant K. So, V by T is constant when P and N are constant. That is the thing that we have to prove. Now, let us come to kinetic gas equation. According to kinetic gas equation, PV is equal to 1/3 Mn C square. This kinetic gas equation can rewrite as PV is equal to 2/3 into half Mn C square. Half Mn C square. Now, this half Mn C square is nothing but kinetic energy of N molecules. So, Ke, kinetic energy of N molecules is equal to half Mn C square. According to kinetic molecular theory of gases, kinetic energy Ke is directly proportional to T, or Ke is equal to K into T, where K is a constant. Now, instead of half Mn C square, we can take this K into T. Now, this kinetic gas equation can again rewrite as PV is equal to 2/3, instead of half Mn C square, you can write K into T. K into T. Here 2/3 is a constant, K is constant, temperature is T, capital T is absolute temperature. Now, V is equal to 2/3 into K by P into T. Now, if pressure P is constant, K is constant, K by P is also constant, and 2/3 into K by P, the whole thing will become another constant. So, instead of all these things, you can write V is equal to constant into T, or V by T is equal to constant. When V by T is constant, when pressure is constant. When pressure is constant, then only V by T is constant. So, this is Charles' law. By this way, we are able to prove Charles' law from kinetic gas equation. Next task is to prove Dalton's law of partial pressures. What is Dalton's law of partial pressure? If two non-reacting gases are kept as a mixture, the total pressure exerted by the gaseous mixture is equal to the sum of the partial pressures of the component gases. Let us explaining. This is one container with volume V. This is another container with same volume V. Here you have gas A and here you have gas B. So the gas molecules, gas A molecules will exert some pressure. These gas molecules in this container will exert some pressure at a temperature T and temperature T. So both containers will have same volume and present at same temperature. Since the masses may differ, that's why the pressure of the gas is PA and pressure of this gas is PB. Now what we are doing, we are placing these two gases in one container with same volume. The new container volume is also same. That is V. The temperature is same. Now what happened? These are A molecules. Let it be B molecules. So whatever the molecules that are present here are brings here. Whatever the molecules that are present are brings here. So both the molecules are kept in one container of same volume at same temperature. Now the pressure is increased naturally. The content of the substance present in that vessel is doubled, approximately doubled. Now the total pressure exerted by these gas molecules P is equal to PA plus PB. This PA is exerted by these gas molecules A, and PB is exerted by gas molecules B. So in a gaseous mixture, the pressure exerted by one component molecules alone is said to be partial pressure of that gas. Here two non-reacting gases A and B are present in the second case in one container. Gas A molecules will exert some pressure, gas B molecules will exert some pressure. So the pressure which was exerted by gas A molecules alone is considered as partial pressure. And the pressure exerted by gas B molecules alone is said to be partial pressure of B. So the total pressure of the gaseous mixture P is equal to PA plus PB. This is Dalton's law. We have a proof there, separate proof we have individually we have done. Now we are going to prove this with the help of kinetic gas equation. According to kinetic gas equation, PV is equal to 1/3 Mn C square. 1/3 Mn C square. Now let us apply this kinetic gas equation for two samples of gases. This is gas A, this is gas B. So gas A, gas B, both have same volume, they occupied same volume, same temperature, they are at same temperature. The pressure exerted by this sample is PA and pressure exerted by this sample is PB. And number of molecules are Na and number of molecules are Nb. And velocity, RMS velocity is Ca and this RMS velocity is Cb. Because only volume and temperatures are same. Since the number of molecules is same, pressure and RMS velocities are also same, different. Now, for this gas, if you apply this formula for this gas, PAV is equal to 1/3 MA NA CA square. For PB second gas, PBV is equal to 1/3 MA MB, NB, CB square. So now the partial pressure of this gas, we can write it as PA is equal 1 by Mn C1 square by V, and PB is equal MB NBC square by V. Now if we keep these two gases in one container, then total pressure exerted by these gas molecules P is equal to, because according to kinetic molecular theory of gases, the influence of one gas molecules or the presence of one gas molecules will not affect the pressure exerted by the other gas molecules, because there will be no attractive or repulsive forces that exist among the gas molecules. So total pressure of the gas will be 1/3 MA NA CA square by V plus 1/3 MB NB CB square by V. But 1/3 MA NA CA square is equal to PA. 1/3 MB NB C square is equal to PB. Therefore, P is equal to PA plus PB. This is known as Dalton's law of partial pressures. Another task is to prove Graham's law of diffusion. Graham's law of diffusion. Graham's law of diffusion. According to Graham's law of diffusion, the rate of diffusion at constant temperature and pressures, the rate of diffusion of a given mass of gas is directly proportional to 1 by root D. That means rate of diffusion of a given gas is directly proportional to square root of its density. This is Graham's law. If two gases at same conditions of temperature and pressures are considered, then the rates are R1 and R2 and densities are D1 and D2, then Graham's law can be written as R1 by R2 is equal to root of D2 by D1. This is another form of Graham's law. Now we have to prove this Graham's law with the help of kinetic gas equation. According to kinetic gas equation, PV is equal to 1/3 Mn C square. PV is equal to 1/3 Mn C square. Or we can write it as P is equal to 1/3 Mn by V into C square. M is the mass of the gas. N is the number of molecules. So M into N is the total mass of the gas, and V is the volume occupied by the gas. Mass by volume is nothing but density. So this expression can be written as P is equal to 1/3 dC square, where D is the density. Mn by V, Mn by V is equal to density D. So when we are comparing, if two gases are taking, then P1 is equal to 1/3 D1 C1 square, and P2 is equal to 1/3 D2 C2 square. When two gases are at same conditions of temperature and pressures, then P1 is equal to P2. When those pressures and temperatures are same, P1 is equal to P2. In such cases, 1/3 D1 C1 square is equal to 1/3 d2 c2 square, or d1 c1 square is equal to d2 c2 square, or you can write it as c1 square by c2 square is equal to d2 by d1, or c1 by c2 is nothing but root of d2 by d1, where c is the RMS velocity. RMS velocity rate is directly proportional to velocity. So c1 by c2 is nothing but r1 by r2. Therefore, it is r1 by r2 is root of d2 by d1. This is the form of Graham's law of diffusion. So by this way, all the gas laws which we discussed earlier independently can be proved with the help of kinetic gas equation.